Okay, welcome back to another complex conjugate video. So this example, we want to prove that Z1 divided by Z2, and if I take the conjugate of that, that's the same as if I take the conjugate separately of the complex numbers, then divide, I get the same value. Okay, as with the other videos, this one is quite long, so I've written the solution now and I'll explain along the way. If you don't understand something, shoot me an email and I'll reply with what I've done. So I'll let Z1 equal x1 plus iy1, Z2 equal x2 plus iy2. So the left-hand side, we want to prove that Z1 divided by Z2, I've written as a fraction, okay? The conjugate of that will equal this. So notice the left-hand side equals that, which in fact equals this. So Z1 divided by Z2 conjugate. Now remember what happens when we divide with a complex number. We multiply by its conjugate, the top and bottom. So that's what I've done. I've taken x2 plus iy2 and multiplied top and bottom by its conjugate. Now remember, when I multiply a complex number with its conjugate, I take this first value and I square it. And I take this second value and I square it. Okay, so that's where I'm at so far. What I've done in this next step is I've separated the denominator for every value. So I've just distributed the denominator, splitting the denominator. Okay, and this is what I get. Okay? The step from here to here, okay, we proved in our multiplication. So I know that the complex conjugate of these, because I'm multiplying, this is just another complex number, this is just another complex number. I can separate the conjugates and write it as it is. So the conjugate of this is this, and the conjugate of this is this. Okay? If you don't understand this step, like I said, shoot me an email. So what happens here, okay, I get this and I distribute, so I put it all under one denominator. So I group x1 minus iy1, and I group x2 plus iy2, and I put it under one denominator. This, in fact, equals this. Because if I want to go from this step to this step, what would I do? I'm dividing by a complex number. I multiply top and bottom by this conjugate. And this conjugate is that. And the denominator, remember, I take that, I square it, I put a plus sign, and I square that. So these two are equal. This, in fact, is the conjugate of Z1 divided by conjugate of Z2, which equates the right-hand side. So there's your proof, okay, of that question. Okay, and these will be really useful in solving further questions involving complex numbers.